All right, so um, kind of jumping into things before we get to material. Let's go down here. So I've got the complete version of last week's slides. So we'll kind of work through the remainder that we didn't cover last week on surplus and shortage to start out. That module 3 quiz didn't have anything with surpluses or shortage, so you could have started it. We've covered all the material that's going to be on that quiz. Although the shortage surplus stuff will be expected on the first exam. We'll then jump into module 4. So before we start, I had the due date set on Top Hat correct, but it for some reason was showing up as the end of the day on Canvas. So just to be fair, in case that confused anyone, I've opened this up on both platforms to be due by the end of the day. So if you didn't get the module reading done before we started module 4 today in class, this might be the one time where you can do it by the end of the day and still get the full credit. Okay. So moving forward, I'll make sure I'm keeping an eye on those dates that they're transferring over from Top Hat correctly and not defaulting to the end of the day. So everything from here on out should be due before we cover it in class. We start covering that module in class. We have new material today and tomorrow. Wednesday will be a review. So right now you should be able to review quiz 1 and quiz 2 because those due dates have passed, as well as all of those participation quizzes. Module 3 quiz and module 4 quiz, which the module 4 quiz, the only thing I have it pulled up here yet, will be posted after class tomorrow. And those are both set to be due at the end of the day Wednesday. So a little bit quicker turnaround on those because they need to be done before we start, before we have that exam on Thursday. Some good study materials for the exam, and we'll go over more of the logistics, especially on that review day on Wednesday. But I've got that practice exam and the answer key sitting up there already on Canvas. You can review that. This will be kind of like your main source of studying. This is like the holy grail for that exam. Now, the quizzes, old quiz questions, you can review those. Every module, the practice problems that you have for those modules will be good for review as well. But the main thing I would feel comfortable with are those materials that in that exam on materials folder, that practice problems, which that's what we'll be reviewing on Wednesday's class. Okay. Other than that, I will post an announcement up about this, but I'll mention it here as well. This week, my office hours the next 2 days. I'm not sure if I'll be here the whole time from 10 to 11, so I can't guarantee that. So I'm going to guarantee that I will be here in between my two sections, which is 12:30 to 2. So in that 1.5 hour time block, I'll have my office hours. I also think I have the setting switch, but it was sending the notifications if someone joined my office. So I usually have the office hours pulled up. I'm working at the same time. It was sending it to my spam folder, so I always keep an eye on my email, and it didn't pop up. So I think I have that changed correctly now. I don't think it was in this section. It was a different section. I had missed someone who was in the office hour. We ended up being able to connect later on. But I wanted to just kind of mention that if for whatever reason you're ever in those virtual office hours and I'm not responding, send me a direct email and it'll kind of give me a notification right away, and I'll jump in if I'm lost in the sauce, so to speak, working on other things. All right. Other than that, it should be all the housekeeping stuff. Any questions for me before we jump back into module 3 and kind of finish out what we didn't cover, starting on this slide 53. Nothing in the chat here. Okay. So what we didn't cover for module 3 is the idea of surpluses and shortages. So up to this point, later on in the classes, we'll have a slightly different definition for us, but for now, we're just thinking about a surplus is the number in terms of the number of units. Okay. So we talked last class about when a market, so if I have a market demand schedule, price and quantity demanded, supply schedule, price and quantity supplied, the equilibrium will be the price where quantity supplied is equal to my quantity demanded. So in our old example, we had an equilibrium price of 3, equilibrium quantity of 15. Let's think about a scenario where, so in this scenario, every single unit being supplied is being purchased by someone. So this might not be, 15 different consumers. It could be one consumer consuming all 15. I'll generally talk about it in terms of like the number of people who want to buy something. So 15 units are being supplied in the market, 15 people want to buy it. Every unit being produced is being sold or purchased by someone. Let's think about if instead we had a price of $5. Well, at that higher price, what would our quantity demanded be? 9. What is our quantity supplied? So at a higher price, producers are going to want to sell more of that product. People aren't going to, or not as many people are going to want to buy it. So we would have here, yes, 25 are being supplied to the market, but if only 9 people are willing to buy it, we're going to have 16 extra units. So whenever that quantity supplied is greater than our quantity demanded, we would say that difference represents a surplus in the number of units. Okay. I'll draw something to go along with this in just a second, but just to set this up to think about, if we have a price that's higher than the equilibrium, we're going to end up with what we call a surplus in the number of units, right? That quantity supplied will be greater than our quantity demanded. Okay. So let's think about, if we have this surplus, what's going to happen. Okay. So anytime we have a price above the equilibrium price, the quantity demanded, notice that every price above this, the quantity demanded is less than our quantity supplied. Okay. So I might jump around a little bit from the slides. Since we've talked about this, I think it'll make a little more sense. So I want to kind of put this in here. So let's say we've got quantity, price. From last class, we said, well, what is upward sloping? Well, this would represent that when the price is getting higher, people are buying, no, not buying more. That doesn't make sense. Oh yeah, our upward sloping supply curve would be, sorry, our upward sloping curve would be our supply curve, representing that when the price is higher, people are willing to supply more units to the market. That represented the producer's marginal costs. And then our downward sloping curve, that said, as price is getting lower, people want to buy more. That was our demand curve, which reflected those consumers' marginal benefits. So where supply was equal to demand, that was kind of our equilibrium, right? That's our equilibrium price. So I just showed you an example where if the price is above that equilibrium, so if we ever have a price that is above the equilibrium price in that market, the quantity demanded will be less than the quantity supplied. And that would be true at any price in this range. So if the price is ever above our equilibrium price in a market, every price in that range, we end up with a surplus in the number of units. Okay. So we'll jump ahead in the slides here so I can add something to this graph, which is, well, what if we have that same supply and demand schedule, but I'm now looking at a price that's below the old equilibrium or my current equilibrium price. Well, at this new equilibrium or at this lower price than my equilibrium of $1, people want to buy 21 of this good, or there's 21 people who want to buy it. Only 5 units are being provided or sold, produced, and put on the market. Well, who cares if 21 people want to buy it? If there's only 5 out there, how many are going to be purchased? Only 5. So there we're going to have how many people want to buy the good but aren't able to. Well, whatever that difference in supply and quantity supply, quantity demand is, that would be our value of our shortage, right? 16 people here want to buy the good, but there aren't any producers that are supplying it, right? 5 of the people that wanted to buy the good could find it, but the other 16 aren't going to be able to purchase it. We'd say there's a shortage here. Okay. So kind of what does that look like visually? If I'm at this lower price, the point where I'm at on my quantity supplied curve is less than the point that I'm at on my quantity or on my demand curve, or the quantity demanded. So that difference would be the value of my shortage. Okay. Another way of visualizing this, anytime we have a price below our equilibrium, so if I have a price below the equilibrium price, that's going to result in what? My quantity supplied, the point I'm at in my supply curve, is less than my quantity demanded. More people want the good than are willing to produce it. So here we would say this would result in a shortage. So any price below the equilibrium, that's going to be the range of prices where we see a shortage would exist. Okay. Any questions on that before we keep moving here? So I've got this in the slides, but I'll go through a little quicker because I think it might be helpful if I draw this out. So let's say we've got a market. I've got my supply, which is marginal costs, my demand curve representing consumers' marginal benefits. And let's say the current price was up here, right? And I think what was this, price of $5, right? So I think at that point we had 9 people. Wait, what was this? Was it 9 and no, 24. No, it doesn't really matter if it lines up with the size or not. So we'll say, I think it was 9 and 26, but if not, it doesn't really matter. So the quantity demanded is less than the quantity supplied. So what's going to happen, right? Well, we have a surplus in the number of units. So remember, the supply curve represented, well, the reason why I was willing to supply this many of units of this good is because the price or the marginal benefit to the producers was equal to or above my marginal cost. So I'll be willing to supply all of these units if the price were this high, right? So it's kind of weird to think about, but when we have a surplus, if there's only 9 people who want to buy this good, after I sell the first 9, what would the marginal benefit be here? Well, even though the price is up here at $5, is there anybody who wants to buy this? No. So what's the actual marginal benefit become? Well, I produce this unit, but it just sits around. So the marginal benefit is essentially 0. Now the marginal benefit is way below my marginal cost. I don't want to produce any of these. So what do producers start doing? Instead of producing 26, even though the price in the market is $5, I know there's not going to be anybody who's willing to buy these additional, well, I said 16, 17 units here. So what do? I start to reduce how many units I'm producing. Well, now I'm willing to supply the last unit at a lower price. At this lower price, more people are willing to buy it. What's happening to that shortage? It's getting smaller and smaller until we get to this point where producers have limited their supply enough to where they are willing to accept a lower price. And then at that lower price, the quantity demanded has now risen to be exactly the same as quantity supplied. And we get back to this equilibrium quantity and then the corresponding equilibrium price. So even if we start out at a price where we have a surplus, market forces, the fact that if I have a surplus, I'm not able to sell it, the marginal benefit to me is 0, firms will start to produce less and less, lowering the price that they're willing to sell it at the market because their marginal costs are going down at the last unit until we get back down to this equilibrium. Okay. So another way of looking at that, right? Let's say I started out, with this surplus, right, at $5. My numbers were off. It was what, 9 and 25, sorry. Well, I just said, because really every unit here, I'm not able to sell it at this price of 5, its marginal benefit is 0. We see that producers start to limit how much they're producing, then lowering the price that they're willing to accept for that, convincing more people to buy it. The value of that surplus is getting smaller. That will continue until we get to where every unit being produced is being purchased by a consumer. We're now back at our equilibrium. Okay. So just when we have a surplus, right? What if we had demand that's too high and we have a shortage? Well, everything would work the exact same, just in the opposite direction. So if at a lower price, I've got this shortage here, right? Well, what's going to happen? Well, 5 producers or 5 units are being supplied to the market, 20 people want to buy it. Well, that means only 5 are able to. There's going to be 15 people who want to buy the good that currently aren't. So what happens? The suppliers see this, they start to produce more. But when they produce more, in order to sell these, they would need a price higher than $1. So they raise the price. As they raise the price, supplying more of these units to the market, fewer people are willing to buy it at this higher price. So that distance between our quantity supplied and our quantity demanded starts to shrink, right? Or the value of the shortage gets smaller and smaller. And then this would continue, right? As long as there's a shortage, well, I still know there's people out there that want to buy the goods, so I'll produce a little bit more. In order to do that, though, I'd have to raise the price. Fewer people are going to want to buy it. And this continues to happen until we get to this point where every unit being produced is being purchased on the market, or the quantity supplied is equal to our quantity demanded. Okay. Any questions on this before we keep moving. Let me make sure. Is the green thing? Okay, you guys can hear me. So this will kind of open us up a little bit to stuff after the next exam. But well, why would we ever see a shortage or a surplus? Like, markets will eventually reach the equilibrium. Why are we worried about these areas? Or why are we worried about these potential zones where the price is not the equilibrium? Well, it's because the government comes in and screws things up, right? So a lot of the times when the government comes in, they'll set prices. We might see that they choose a price and it's not the equilibrium. And so potentially they can create a shortage or a surplus. Right? So an example of this, gasoline in the 70s, they capped oil prices, right? So it limited the price that you could charge for a gallon of oil, a gallon, probably not a gallon, a barrel of oil. There we go. Which led to higher gas price, or sorry, which led to lower gas prices. And at lower gas prices, yeah, more people wanted to buy it, but do producers want to produce and sell as much as if the price isn't higher? No. So their quantity supplied went down. Now our quantity supplied is below quantity demanded, and we have a shortage. Another way of thinking about this, kind of an interesting market, and you could think of this actually before I do this one. The labor market, another way the government will come in and set prices is sometimes instead of a lower price, whatever the current equilibrium wage is, they'll put a minimum wage. That's making sure the price is higher. If they make the price higher than the equilibrium, we said what's going to happen? A surplus in the number of units. So to kind of think about this, let's say I had another example is apartments, right? And then I have kind of the price of apartments, or you could think of what's the price of an apartment, rent. So we would have our supply and our demand curve, whatever that current equilibrium rent is or price. If the government comes in and says, well, we think that rent's way too high, no one can afford this, so we're going to limit the price that you can charge, right? So this might be something like a rent control, right? You can't charge a rental price for this specific type of apartment for a bedroom over this amount. Well, that might sound good in practice, but what's going to happen? At this lower price, yes, more people are willing and able to rent an apartment, but are companies willing to build as many apartment complexes and sell as many? No. At this lower price, the quantity supplied will actually go down. Now, what have we created? If quantity supplied is less than quantity demanded, or we artificially set the price below the equilibrium, we've created a what? A shortage, which a shortage in the number of apartments means people don't have a place to live, right? So that's not a good thing. Okay. So the government can kind of is really the one where we worry about surpluses and shortages because they can come in and artificially set prices. It doesn't allow the market to now increase the price, get back to that equilibrium. Okay. You could think of a similar, or not similar, but a different type of example. So I said the labor market. So this might be like the quantity of labor or number of workers for minimum wage jobs. Well, here the price of labor is wage, right? So maybe we have an example where here's kind of the current equilibrium wage. And wage is really just a fancy term for the price of labor, right? Well, if I set a minimum wage and I say you can't pay people any less than this, I'm essentially raising the price above the equilibrium. We said, well, what happens there? Now my quantity demanded is less than my quantity supplied. What have I created? A surplus, which it might sound good if we don't stop and think about what is a surplus of workers? Unemployment, right? It's people who would be willing to work, but there's no one willing to kind of hire them now. Right? So this is just kind of, we'll go through price ceilings and floors in a later chapter, but just introducing the idea now that when we have these different prices that aren't the equilibrium price, we can create shortages and surpluses. Now, if they're not government, enforced, they're not enforced, and these are just like it happens to be the current price is this, market pressure will either push it up or down to that equilibrium price. But if it's the government, they can stop that from happening. Okay. All right. Any questions on anything there before we jump into module 4? Okay. All right. So module 4 slides. Let's get this out of the way here. So we're going to be talking about, well, come on, go away. The price elasticity of demand. Okay. So we've got our supply curve, we've got our demand curve. We're now going to start to talk about some different characteristics of it. Right? We've talked about slope. We're now going to talk about elasticity. So what is elasticity? So the price elasticity of demand is essentially a measure of how responsive, anytime you see this word elastic, you can think of it like a rubber band. How responsive is this material to an applied force? So rubber bands are very elastic when we apply force to them. This desk, I can apply force to it. It's not going to break. It's not going to give. It's not elastic, or we would say it's inelastic. We can measure the same sort of thing, not in like terms of physics, but in terms of just the responsiveness of supply or demand to changes in, not the force being applied is changes in the price. Okay. So the price elasticity of demand. Next class, we're going to talk about a bunch of different elasticities. So just to kind of set us up for that, whenever I say blank elasticity of blank, right? So some X word, some Y word. For us, this is the price elasticity of demand, right? So this is going to be how responsive is that second word, we're talking about the elasticity of demand. So how responsive is demand to changes in that first word? So the first word is the thing that's changing. So for us, that's going to be how responsive is demand to initial changes in price. And that's what we'll focus on today. Next class, we'll talk about income elasticities of demand, price elasticity of supply, and some other elasticities as well. Okay. All right. So not only are we wanting to measure how responsive demand is to price changes, we want to be able to compare this across goods. And in order to do so, I'm not just going to look at the changes in the quantity demanded from a change in price, because if I look at like oil, the change in the units would be barrels of oil. Well, what if I wanted to compare that to textbooks? It's just the number of, those are very different units, barrels and the number of books, right? Or you can think about this as, maybe I'm looking at something that's measured in pounds and as the units, and the other thing is measured in, I don't know, the gallons or whatever it is, right? So we're not going to keep it in units. We want a unitless measure. So the way that we can get a unitless measure is look at not just changes, but percentage changes. So when we say how responsive is demand, we say what is the percentage change in quantity demanded from a percentage change in price. Right? So anytime we're looking at percentage changes, we now have a unit-free measure. Okay. Now we can compare the price elasticity of demand for gasoline to the price elasticity for fast food hamburgers, to the price elasticity for bottles of water, etc. Okay. So I'm going to kind of use this delta to represent change instead of writing the word out here, but it's a percentage change in quantity demanded over the percentage change in price. Now, I'll focus on this a little bit more later on in the class, but you'll notice elasticity is calculated a little bit differently than slope. So slope and elasticity are not the same thing. They are related, and we'll talk more about that relationship later on. But when we're doing slope, we had what? The change in. So when we had a demand curve, what was on our y-axis? Price. Quantity was on the x-axis. So our slope was the change in price over the change in quantity. Notice for our elasticity of demand, price is in our denominator and the quantity demanded is in our numerator. So when we're calculating elasticities, the thing that goes in your denominator is the initial thing that's changing. So the price is changing, and then how responsive is demand whatever is responding, that's what's going to go in your numerator. Okay. So just to kind of set up a little easy example here, if I was calculating the price elasticity of demand, let's say Netflix is worried about losing too many consumers from current or recent price increases. So they increase their price by 50%. As a result, they see that the number of accounts they have or people that have bought their good has went down by 25. All I'm doing there is plugging in what that percentage change is. Percent change in price was 50. Percent change in the quantity demand, it went down by 25. I'd have a price elasticity of demand of negative 0.5. Okay. Now, it's negative here, right? So how do we kind of interpret this? Well, we'll come back to the interpretation when we talk about elasticities in just a second. But like, what does this number actually tell us? Well, the smaller the number, think about it, as your numerator gets smaller here, let's say we had the same 50% increase in price, the smaller that number gets, that means that the change in quantity is going down or that people are being not as responsive. So a smaller number here actually means that people are inelastic. They are not responsive. A larger number means that they're very responsive, right? If you change the price by 50%, maybe I react by 250%. I'm very responsive the larger this elasticity gets. Now I'm saying larger here to make it a little bit easier in the way that we talk, and also then to compare, say, the price elasticity of demand to the price elasticity of supply. We know the price elasticity of demand will always be negative. Why? Because we said this relationship that exists between price and quantity demanded is inverse. So because we know it's always going to be negative, we're actually going to just look at the absolute value. Okay. So the absolute value for the price elasticity of demand, that'll drop the negative sign. Now we can start to think about when this elasticity is getting higher and higher and higher, larger and larger value, it's being more elastic. When it's getting closer and closer to zero, there we would have examples of things that are not responsive or what we would call inelastic. Okay. So how do we calculate these percent changes? We'll kind of come back to this in a second. I'm going to skip ahead a little bit, and we're going to talk about these different ranges we can see this measure of elasticity be. Okay. So the fact that this is measuring the responsiveness of demand to price changes, let's think about if I have a percent change in quantity demanded, and it's less than my percentage change in price. Okay. So our elasticity of demand was the absolute value of the percent change in the quantity demanded over the percentage change in price. So anytime I have like a relationship like this is less than this, I always choose numbers. Sometimes it's pretty extreme to really like let this point sink in. So if I had, let's say, a 100% change in price, and as a result, people only reduced how much they're buying by 1%. Well, that's a large change in the price, percent change in the price, small percent change in how much people are buying. People are not being very responsive. If I compute this, I'd have what? 0.01 or something pretty close to zero. Okay. So anytime I'm getting closer and closer to zero, that means people are not very responsive. We would say that demand here is inelastic. I'll even foreshadow a little bit more. What would be perfectly inelastic? If people didn't respond at all to a price change. If people don't respond at all, what would this change be? Zero. So an elasticity measure of zero, we would say that would actually be perfectly inelastic. I'm not responding at all to this price change. Okay. We then could think about, okay, what if the reverse was true? All right. So what if I had an elasticity of demand and I had a relatively small percent change in the price, and as a result, people bought a lot less. So 1% change in the price, people change how much they're buying by 100%. Well, that's really responsive, right? This would be what? 100? Anything that's over 1, so anytime that numerator is greater than our denominator, right? We're going to say that demand is elastic. So up here, when would it be inelastic? Well, I said anything close to zero. Anytime your numerator is less than that denominator, we're going to end up with an elasticity that is less than 1. Okay. So an elasticity less than 1, we're going to have inelastic demand. That's telling us that the numerator is less than the denominator, or that the percentage change in the quantity demanded is less than the percentage change in price. Anytime we have a percentage change in the quantity demanded that's greater than that percentage change in price, people are being very responsive. That would be an elasticity that's greater than 1. We would say demand is elastic. Okay. And then we have this kind of weird one in the middle. So let's say I have that same idea. I've got my elasticity of demand. And now maybe I see a 1% change in the price. And as a result, people change how much they're buying also by 1%. So they're like almost, you can think about it like perfectly responding to that price change. Here, if I have the exact same percent change in the quantity demanded as my price, what would my elasticity be here? Anything divided by itself, taking the absolute value, would be 1. We'll call this unit elastic. So anytime the percent change in the quantity demanded or how responsive people are, they're like, you can think about this almost like they're perfectly responding to that price change. It's like a 1-to-1% response. That would be what we call unit elastic. Okay. And I think I have this kind of broken down in the slides, but just kind of building out, talking through, I think is helpful. I'll also show you another way of visualizing this. I think this maybe it'll help some people. I'm hoping it helps, quite a few. So I'm actually going to put this here if you're taking note. Well, I think I can do this, hopefully. I think I got enough room. Well, I'll give you guys a second to kind of get this down because I want to take this away here. So let me do this. There we go. So another way of thinking about this is when we take that absolute value, the lowest possible elasticity we could see is 0. So anything in the range of 0 to like 0.9999, that's less than 1. We would say that that is inelastic demand. Okay. Anything that is exactly equal to 1, we would say that's unit elastic. And then anything slightly above 1 all the way to infinity, we would say that demand there would be elastic. Okay. Just another way of kind of visualizing those different categories. Okay. Any questions before we keep moving here? So here's get this off the screen. There we go. Here are my 3 ranges, right? Inelastic demand, less than 1, which would imply the only way this fraction is less than 1 is when the numerator is smaller than my denominator, or that people are not as responsive as the change in price. Greater than 1 is elastic. That would mean my numerator has to be greater than my denominator, or the percent change in demand is greater than that percentage change in price. If it's ever equal to 1, these would have to be the same number, which would imply for every percent change in price, I have the exact same percent change in how much I'm demanding or my quantity demanded. Okay. So with this idea in mind, these different ranges, we're going to talk a little bit more specifically about how I calculate my percentage change in price and quantity demanded. Okay. So here, I've got an example for setting up why we need to use what we call the midpoint method. Okay. So if you're thinking about like a percentage change, let's say I was starting at a price of 100 going to 80. Well, if I use kind of what is that more, I guess, traditional or how most people think about percentage changes, it's from the point you start out. If I do it this way, if I go down by $20, but I start at 100, what is 20% of 100? That would be $20. So going from 100 to 80, that would be a 20% decrease. However, if I move between those same 2 points, 80 and 100, well, because my starting point is different, what is that same $20 change in price? Well, if I start at 80, that $20 is actually a 25% increase. So even moving between the same 2 prices, if I use that original starting price to calculate my percent, I would have two different percentages. So what are we going to do with the midpoint method? Essentially, we're going to take the average of the two. Right? Now, an easier way, instead of computing each one of these, to calculate our percentage changes. So anytime you want a percentage change, so I'll start out just kind of thinking about how you would do this for quantity. You are going to take, well, I'm going to break this down step by step. You're going to take a change in that quantity demanded and then divide it by the average between the 2 points that you're looking at. How do I find a change in something? That's take your new quantity minus your old quantity. How do I find the average of two numbers? Well, that would simply be adding those two numbers up and dividing by 2. Okay. So the midpoint method says take those 2 points, whatever the change is, divide it by the average of those 2 points. That way, it doesn't matter if you're moving from 100 to 80 or 80 to 100. The midpoint method, when you plug 80 and 100 in, you would get the exact same percentage change. So we're going to do the exact same thing to calculate our percent change in price, right? So if I want my elasticity of demand, that's my percentage change in the quantity demanded, which we just said, this is how I would calculate it. But we also want the percentage change in price. So how would I find my percentage change in price? That would be the change in price. So just my new price minus my old price, divided by the average of those two prices. Simply add them up, divide by 2. And then we have an elasticity. So we're still going to look at the absolute value. Okay. So I've got this color coded to be a little bit different here. So let's say I wanted to find the elasticity of demand. We calculate the percentage change in quantity demanded by the change in quantity over the average. And then the percentage change in price is the change in price over the average. I can break this down. So my change is just new quantity minus old, change in price, new price minus old, the average, add those two up, divide by 2. This is how we would use the midpoint method to calculate our percent changes in quantity demanded, percentage change in price, then take the absolute value to get our price elasticity of demand. Okay. Any questions on this idea? And I'll go through an example here in a second. Okay. So let's say I've got two prices. I'm moving from $6 to $4, and the resulting change in the quantity demanded, people want to go from wanting to buy 15 units to 25. I'm going to use that midpoint formula, right? And I'll put up a formula sheet that I would kind of suggest I would usually give you if we were doing this in-person exam. And it'll have that midpoint formula on there so that you can just simply look at that change in quantity over the average, change in price over the average. Once you plug all those values in, 25 was our new quantity, minus 15. So this is what, 10 divided by what's the average of those two. With these simple numbers, it's a little bit easier to kind of just eyeball it. The average would be 20. Change in price was 2 over the average price. The average between 6 and 4 would be 5. We end up with this elasticity of demand of 1.25. That tells us that demand here would be elastic. Okay. Now, one thing going on kind of behind the scenes here, we just computed using the midpoint method. This numerator should represent our percent change in quantity demanded. The denominator should represent the percent change in price. So we should have what, 0.5 over negative 0.4 if I enter these fractions into my calculator. So even though we're thinking about percentage changes, when we use the midpoint method, we came up with 0.5 over negative 0.4 here. And we're taking the absolute value, so it drops the negative sign. So when we're looking at the actual math of it, yes, our numerator still represents a percentage change in the quantity demanded, but the intermediate calculations will not be in percentage like 100% or 50%. They'll be in decimal form. So notice this is actually a, kind of think about it as a 50% change in the quantity demanded, and this represented a 40% decrease in price. But if you do, this works out to be the exact same value of 1.25. So when you calculate those percent changes using the midpoint method, they will be your percentage change. It's just that they're in decimal form, right? If you're just directly given the percentages, well, then it's just as easy. You just got to plug these in. You don't even have to use the midpoint method. Okay. Any questions there before we keep moving? Okay, so we already talked about these ranges. The next thing we'll talk about is that the slope of our demand curves and these elasticity ranges, the slope and elasticity are related, but they're not the same thing. Right? In fact, they're inversely related. So a general rule of thumb, and I think this will make a little more sense when we work through the next five, 6 slides, is that the flatter the curve, right? So the flatter the curve would mean the lower the slope, the higher the elasticity, right? So they work in opposite directions. The flatter the curve, the flatter the curve, the higher the elasticity, which means it's more elastic. The steeper the curve, the smaller the elasticity, it's going to be inelastic or less elastic. Okay? So I think what can really help with this is let's look at the two extremes. Okay? So the first extreme is a perfectly inelastic demand curve. Okay? So if I have a completely vertical demand curve, what's that telling me? Well, that's saying, okay, the percent change in the price could be anything, 10, 20, 30, 40. But if the price changes here, what's happening to the quantity demanded? Well, if I had a completely vertical demand curve, it stays exactly the same. So my percent change in quantity would always be 0. So with a completely vertical demand curve, what is my elasticity? Well, 0 over anything is going to be 0. Now, what's the slope of this completely vertical demand curve? So remember, when we're calculating slope, so here's my demand curve. Slope is going to be change in y over change in x, or change in price over change in quantity, right? Or quantity demanded, to be a little more precise here. Well, here, I'm going to have some percent change, or sorry, I'm going to have some change in the price. What's going to be the change in the quantity demanded? Always 0. So anything divided by 0 is what? Infinite. And in fact, it's downward sloping, so we kind of say like negative infinity. Right? So my slope is negative infinity for this completely vertical demand curve. But we said, what's the elasticity of demand? Well, my percent change in the quantity demanded over my percentage change in price. Remember, price is in the denominator now. So I'm going to have anything above 0, or sorry, 0 divided by anything above 0. So this is always going to be an elasticity of 0. So when elasticity is 0, your slope is actually infinite. So these are kind of exact flip-flops of each other. Okay. And since we have it here, I'll draw next to it. And I have got a slide we can kind of look at here in a second. But let's say I had, instead of a completely vertical demand curve, what if my demand curve was perfectly horizontal? All right. Well, if I'm moving in between these two quantities, the price could stay exactly the same. So if I'm thinking about my slope, that's the change in price over my change in quantity demanded. Here, I've got no change in the price, and I'm still seeing that the quantity can change. 0 over anything is a slope of flat curve, completely horizontal, would have a slope of 0. But the elasticity of demand, percentage change in quantity demanded over my percentage change in price, well, there I have some change in my quantity demanded, no change in price, anything over 0, and I take the absolute value. Okay, my elasticity here is actually infinite, and the slope is 0. So notice there's an inverse relationship, right? When the elasticity is at its lowest point, the slope is at its highest point. When the elasticity is at its highest point, the slope is at its lowest point. So if I'm going from perfectly inelastic, see here, we said this represented no response, right? There was no change in the quantity demanded. To really responsive, I was responding even when there wasn't a price change. As I go from vertical to horizontal, the demand is going from perfectly inelastic to perfectly elastic. So the flatter the slope, the more elastic my demand is getting. Okay. So these are the two extremes. What about the points in between? Okay. So here I've got perfectly inelastic demand. If I can get my mouse to, there we go. What if it's really pretty steep, but not completely vertical? Well, if it's really steep, I could see relatively large percentage changes in price, and the percent change in the quantity demanded is going to be much lower. So if this is a value less than 10 divided by 10, this fraction would be less than 1, which means we know here demand is going to be inelastic. Okay. So when things are inelastic, I can change the price. In fact, just to kind of put some more extreme values to it, even if it's not perfectly elastic, but it's somewhat inelastic, why might companies really like this? So if I've got a relatively steep demand curve, not perfectly vertical, but pretty steep, there I could see a really large change in the percent change in the price, right? So there my percent change in the price. I could increase the price by a ton. What's happening to my quantity demanded? My percent change in the quantity demanded would be, it goes down by a much smaller amount. So when my elasticity of demand, when I've got the percentage change in the quantity demanded over my percentage change in price, when this is a really large increase, this is a small decrease, less than 1, so we would have like a steep curve would be pretty inelastic. Well, think about how much money I'm making. So we'll kind of simplify this down to the revenues we're making is just the number of units I'm selling times the price I can charge. Well, if I've just increased the price by a huge percent, and as a result, people don't buy that much less, the overall effect of my total revenues are going to be that I can increase them. And I think it's kind of intuitive. If I have a product and I can change the price and people don't buy that, or I can increase the price, I should say, and people don't buy that much less, right? They're very inelastic to that price change. That's going to be good for me as a company. So I think this guy's name is Martin Shkreli, or Shkreli sound like that's like a old cartoon. I forget what his last name is, but he bought the rights to this HIV drug that had a patent, so it's the only one that was available. So if you had HIV, he was like, yeah, I can increase the price by a ton. I know that you're going to keep buying the same amount of this drug, so you're not going to buy that much less. Companies really like these inelastic products. Okay. And then we already talked about the other extremes. So perfectly elastic demand would be horizontal. So we kind of already worked through this one. What if it's not perfectly elastic, but pretty flat? Well, there I could still see a pretty small change in price, and it would result in a much larger percent change in quantity. So if my numerator is greater than my denominator, I'd have a elasticity measure greater than 1. I'd have fairly elastic demand. Okay. Where are we at on time? Okay, I think we have enough time to do this. Just to kind of show you another kind of extreme, but not the extreme of this. So if I wanted to think about what would like an elastic product look like, can you guys still see what I'm drawing here okay? The light's turned off of me and I can see all right, but I just want to make sure that everything's showing up to you okay. Okay, so let's say I had not a perfectly flat demand curve, but pretty flat. Well, there, I could see a relatively small increase in the price. And what would happen? I'd see a much larger percent decrease in the coin demanded. So once again, just to kind of give us a little bit of an insight into some things we'll talk about next class. Here, if I've got an elasticity of demand that's greater than 1, or what I have depicted here, that implies that the numerator, right, must be greater than my denominator in order for this fraction to be greater than 1. So if I have pretty elastic demand, I know that when I have a relatively small percent change in price, that's going to result in a very large decrease in the amount that people are buying. So increasing the price by little causes the amount people buy to go down by a lot. Overall effect is I'm going to see that people decrease, or sorry, increasing that price will decrease my total revenues, which for a company is a bad thing. All right, so these companies like inelastic products, not elastic products. Okay. And then one other range, anytime you have the percent change in the quantity demanded is the exact same as the percent change in price, this fraction would always be 1. That's what we would call unit elastic. So there, consumers, the way I say it is, and it gets, I don't want to confuse you, but they're like perfectly responding to that price change. For every 1% change in the price, their percent change in how much they're buying is the exact same percent, right? Any questions on that? Okay. All right. So we've got 25 minutes. All right, we'll talk through these things. I think we'll have enough time then for the quiz, and then we'll start on the stuff in the next class. So we've now talked about calculating this price elasticity of demand. And the reason why I spend more time today talking about just the price elasticity of demand, even though we'll talk about other elasticities, is we're going to compute all of them in a very similar way. Okay? So this midpoint method can be used to calculate all types of elasticities. It's just instead of quantity demanded and price, maybe we have price and quantity supplied, income and quantity demanded, etc. So we'll talk more all about all of that next class. The rest of today's class, we're going to talk about things that would change whether or not a good is elastic or inelastic, or determinants of this elasticity of demand. So the first thing is going to be if I've got a lot of available substitutes. Right? So I've got in here kind of some examples and things like that. But we'll talk through, I'll kind of give you some shorthand here to thinking about this in a different way. So let's say I think about a good, and all of a sudden there are more substitutes. Right? So you could think of this even as like you live in an area, there's one electric company, right? Well, if instead there was multiple electric companies now competing for your dollar, right, for you to have electricity with them, what's going to happen? Okay. So the more substitutes you have, if there's a percentage change in the price, do you think people are going to be more or less responsive than they were before? Well, before, if there was one electric company and they increased the price, well, what might be true? Percent change in quantity demanded might be pretty much the same. If I need electric, I've got to get it from this one company. But when there's more substitutes that increase in the price, I now have other options. So if one company increases their price, what do? I switch to another company. This could be really large, right? This could be, something above 0 or be closer to infinity, really responsive. So the more substitutes that are available, the more responsive people will be to price changes. Right? So when there's more substitutes available, it's likely we're going to see an elasticity that's greater than 1, right? Making that good more elastic. Okay. So more substitutes means we're more responsive to price changes because we now have options. If there's fewer substitutes, or I guess less substitutes, I should write this grammatically correct. Fewer substitutes, right? From that same change in price, we're now going to be less responsive. This was the idea that if there's only one electric company, being less responsive means the elasticity is likely to be less than 1, or we're more likely to be inelastic, or said differently, we are less elastic. So what are some examples that we can kind of think through for this? So we'll think about things with more substitutes. So I always think of like if I'm choosing to get something for lunch, you could do fast food burgers, but let's think about like I go down, I could get Chipotle, Chick-fil-A, McDonald's, Burger King, all these places. If one of them increases their price Am I going to be really responsive to that? Well, if there's many, many other substitutes, then yeah, I'm much more likely to not buy their product and go buy someone else's, right? So the other example I use for this is like gas stations, right? There's a ton of different gas companies. If one of them changes their price, even by a little, really small percent change in price, well, if there's multiple gas stations in every corner, the one that increases their price is going to be the one that I don't buy from. So even a small pennies, right? Small percent change in price, the quantity demanded of their gas might go down by a lot. That means demand is really responsive. So more substitutes and more similar substitutes, we would say demand there is going to be more elastic. Okay. And then on the flip side, if there's fewer substitutes, so I already used the electricity example, but this is another thing I would use an example of is like think about Super Bowl tickets. So they could change the price by a lot. That percent change in price could be really high. So you'd have a high denominator in your elasticity measure. But even if they double the price of the tickets, the Super Bowl is probably still going to sell out. Why? Because if people want to go to the Super Bowl, there's not a substitute, right? There's not another championship game for the NFL being played anywhere else. Right? So goods that have very few or substitutes that aren't similar to them at all, those would be things we think of are more inelastic or less elastic. Right? It's two different ways of saying the same thing. Okay. Not to get too off topic here, but if substitutes matter for elasticity, and we said that companies like to have an inelastic product, I would like for people to, be able to charge a higher price and people not respond very much to that. So they keep buying the same amount, but I can sell it for a higher price. I'm going to make a lot more money. So how can I make my product more inelastic? Create fewer substitutes. Well, that's kind of hard to do. I can't just create fewer substitutes for, say gasoline. But what can I do? Well, I can market. I can make people think that Shell gasoline is so much better than everyone, even though it's all regulated, it's the exact same. Or, maybe not gasoline is a bad example, but, I don't know. If you look at the recipes for Pepsi versus knockoff brands, they're pretty much doing this. I mean, the knockoff brands just try to imitate what Pepsi's doing. So, and you can back engineer anything. So they're probably giving you like the same product. But what does Pepsi convince you of? That theirs is it just is different, right? And if they can convince you that there aren't substitutes, well, as long as they convince you there aren't substitutes, your demand will be less elastic. For them, that's a good thing. Okay. All right. Another determinant of demand elasticity we will talk about is the proportion of your income you're spending on something. So the general rule of thumb is if I'm spending more money on something, and I'll kind of use intuition here, I think, to break this down, and I'll mention something at the end of this slide. If you're spending a higher proportion of your income on something, the end result is you're going to be more elastic. Well, why? So I'll use the example of you probably have a pretty fixed income right now in college, and this applies really to anyone, but a housing purchase or a rental decision or a car purchase is going to be a large portion of your income. So what do people do? People are really, really sensitive to rent changes. So I remember when I was in college, like I would look at things, and obviously they're much different now. And I was looking at really shady apartments, if I'm being honest. But I was looking at $500 versus $550 in rent in a month. That was a very small percent change in the price, but it was a large portion of my income. So I was much more likely to not buy that apartment that was sign a lease for that apartment that was 550 versus 500. So even though there was a small difference, small change in the price, my percent change in the quantity demanded was really large. Right? Putting this in the context of a housing decision, well, percent changes in my housing decisions will always be large. Why? Because I'm usually just going from 0 or 1 to 1. That's a very large percent change in the quantity demanded. People over like a $500,000 house will haggle and not make a deal sometimes over like closing cost disputes of like a couple $1,000s. That is such a small change or difference in the price, and their percent change in quantity demanded, buying the house or not, will be really large. Well, that's very elastic demand, right? When something is a higher portion of my income, think about this as I care more about it. When I'm going to go out and buy a house or a car, I look at a bunch of different houses. I look at a bunch of different cars. I shop around for the best deals. I'm really sensitive to price. Now, if something's not a high portion of my income, so this is where my wife will joke I have like greatest hits. So I apologize if I use the same examples or mention the same things about me throughout the semester. But I have a fountain drink addiction to Diet Mountain Dew. And so let's think about my demand for Mountain Dew. If I went down to the Circle K right now, I'm getting a 44 ounce of Diet Mountain Dew for the day. If it's 50 cents and they increase the price to $1, that's like what? If you use the midpoint method, that's a 66, if I'm doing math in my head correct, percent increase in the price. Regardless, a large percent change in the price. No matter if it was 50 cents or $1, I'm probably going to buy one fountain drink from them. So there, I didn't change my quantity demanded at all. So my demand, but there was a percent change in price. So my elasticity of demand would be 0. I'm perfectly inelastic to that price change when it's a very small portion of my income. Now, if I was spending $1,000 or a larger portion of my income, and instead of 500, they want to charge $1,000 for this, I'm much more likely to be a lot more sensitive to that. So things that are a small portion of your income, you could see a really large percent change in their price, and you might keep buying about the same amount, right? You're going to be very inelastic to price changes if it's a small portion of your income, of your income. Okay. Is that making sense? Any questions on that idea? Now, in all of these things, so whether it's like something that's a high proportion or small proportion of your income, something that has a lot of substitutes or not many, try to think of goods that make sense to you. So if a housing decision being a large portion of your income doesn't make sense, think of something if you bought it, would be a large portion of your income that you would be really sensitive to changing the price, or you would really care about getting a good deal. That might be a less technical way of thinking about being elastic, is things that you're really trying to shop around and get a good deal on. It's likely because it's a high proportion of your income. Think of a good that makes sense to you, right? And then that helps anchor this idea to like your personal life. Or think of something that you buy often that's a small proportion of your income that when you really stop and think about it, yeah, I'm not really that sensitive to price changes, right? Because even though maybe it's like only a difference of like 25 cents, if it's a really large percentage change in price, I'm not being very responsive to that. Okay. I try to give some examples that make sense to me or I think might make sense to a vast majority of you. Obviously, I can't sit here and run through 20 different examples, but try to use one that makes sense to you in your life so that kind of helps anchor this idea. The last determinant that we'll talk about is the length of time to make a decision. So we've really kind of already talked about this, but if I have more time to make a decision, right, what can I find more of? So let's say I have a lot of time, and I'll use an example from my life right now. I've been shopping around insurance, right? Car and home insurance. There's a lot of different companies out there. I've been looking at a lot of different prices, but it takes time to get quotes from them. But I've paid up through the next couple months, so I'm kind of thinking about 2 or 3 months down the road when I'm changing insurance. I have a lot of time. I can go out and find a lot more substitutes. I can get quotes from a lot more companies, so I can be more elastic. I'm a lot more sensitive to price differences or price changes because I have more time to make that decision. And even small changes in price might result from me buying 0 insurance policies from that company to buying 1. That's a large percent change in the quantity demanded. So numerator would be large, denominator, relatively small percent change in price. I'd have elastic demand. Now, another example of this might be, so if I have less time to make a decision, so let's say my insurance policy runs out today. I got to have car insurance tomorrow or I'm driving around without, insurance, which is illegal. I might be way less sensitive, right? Someone could give me a quote. I don't have enough time to get other quotes. Even if it's a little bit high, I might be like, yeah, I got to have insurance tomorrow, right? So there, I'm not going to be near as sensitive or responsive to price changes if I don't have as much time to make a decision. I can't go out and get quotes from other companies. Okay. Another example of kind of more or less time to make a decision, I always think about this in the context of like getting gas for your car. If I need to take a trip today, and I only have 20 gallons in my tank, and I got to go to Indianapolis, I got to pay whatever the price of gas is today, right? I got to pay as whatever gas station where within that small radius that I can get to and get gas. If I don't have a lot of time, I need gas soon because I don't have enough to drive more than 15 minutes. I've got to pay whatever the price is. I can't be very sensitive to price changes. Now, if I've got enough gas in my tank, right, to drive around for the week and I'm not taking a big treat big trip until the end of the week, well, I can drive around and kind of shop around and look, okay, wait, maybe a gas prices are supposed to go down tomorrow. I'll wait and kind of see, or I can have more time. I can find more substitutes, right? I can be more sensitive to price changes if I have more time to make that decision. Okay. So those are kind of the two examples I always use. There's another easy one that'll make sense here in a second, but I've got a visual to go along with it. But more time, I can be more elastic because I can find more substitutes. Less time, less elastic. I don't have as much time to find substitutes. So I've got like a set of goods here. We'll kind of talk through just some determinants of these goods that make them more or less elastic. So the first one, this was put out by a company that did some data collection and did some price elasticity measures for the average consumer. Notice like a book of matches. First of all, not many people are carrying or using these very much anymore, but they're a relatively low proportion of your income, and all matches are the same. So no matter where you're getting, they're all a lot of substitutes, available substitutes. They're all the same product, right? And so small changes in the price there, well, you would think, oh, I've got a lot of substitutes. That should make it more elastic, but it's a really small proportion of your income. So that is what kind of weighs out that like that's making it a really inelastic good, right? Kind of like my fountain drink example. Yeah, I can go get a fountain drink from a lot of other places. There are a lot of substitutes, but man, that's a small proportion of people's income. They're going to be very inelastic, really close to zero. Now, using these two, short run and long run airlines, really interesting to kind of highlight this last determinant we talked about, which is time. When people need to get a flight out in the next 24 to 48 hours, what do you think is probably true about the price they have to pay if they want to get on that flight? If they want to have a quantity to buy one ticket, right, keep that quantity, go from 0 to 1, they're going to pay whatever the current price is. Right? If they want to get to their destination, they can't be sensitive to price changes. If they have to be there tomorrow, they've got to pay whatever the current prices are. So they're very inelastic. But if I've got the next 3 months to plan this trip and wait and for, kind of check every couple days, find a really low price, I can be really sensitive what the current prices are. So there, when you have a longer time frame to buy that ticket, airline ticket, we find consumers are a lot more elastic. They can find more substitutes, right? In terms of like different companies they can buy it from. Another good example of this long run, short run, kind of like airline tickets. If you've ever like tried to get Airbnbs, if you need an Airbnb for this weekend, first of all, it's the 4th, but if you need one in the next couple days, you really are going to be paying high prices. Why? Because they know if you want to book that trip, you've got to do it now or you're not going to be able to find it. Like they're all going to be booked up. If you want to go, you don't have time to shop around or even look for like hotels aren't likely to have availability. So in the short run, Airbnb prices are going to be a lot higher. Why? Because companies know, the people renting these know, people are going to be more inelastic. Now, if you're running Airbnb a couple months out, well, there you've got a lot of time to shop around, look for a place that's very similar at a lower cost. So in the long run, you don't see prices be quite as high because there, Airbnb places know that consumers are going to be a lot more elastic, more sensitive to price changes. So don't give yourself less time because their companies will take advantage of the fact they know your demand is more inelastic. Another thing that was kind of interesting here, tobacco, if you want a nicotine or a caffeine high, maybe there's not as many other available substitutes. So you have pretty inelastic demand. Also, they're a relatively small proportion of your income when you're buying any one unit of these goods. And so we see there we kind of have some pretty low elasticity measures. Housing, education, like college, people are a lot more responsive to price changes, or we have above 1, so elastic demand there. Something that's a high proportion of your income, but you still have a lot of substitutes. So both those things would make it more elastic. So like brand new Chevy cars, well, A, it's going to be a high proportion of your income. So you're going to be more sensitive to price changes. But also if we're specifically talking about a Chevy, you've got a lot of other companies you can buy from, Honda, Kia, etc. So you have a lot of available substitutes, making that product, at least on this short list, the most elastic that we see here. And then restaurant meals, not a huge proportion of your income, but a lot of available substitutes. So we see those being pretty elastic as well. So just some different goods to think about, some different traits, why they might be elastic or inelastic. Any questions over anything I mentioned there, or something I said didn't make sense about one of the goods? Talking a little bit quick here. Okay, and then I had one that I thought was just useful in making a point. And I don't know, these different alcohols, we could go through each one individually, why they're more or less elastic. But I wanted to use this more to make the point. When you look at a general category of a good, so like this was the total elasticity measure for all alcohol drinks combined. So it looks like it's what, negative 0.5 absolute value. It's fairly inelastic. But you'll notice for the same good, right, category, you could break this down into different types. And I don't know, maybe blended Scotch whiskey, like these really high-end whiskeys, people don't think there's as many available substitutes. Like if you really want a really good whiskey, there's not a whole lot. You don't think that these cheaper kind of premixes or some of the single malts are near as flavorful or whatever it is, you might be more inelastic. But within that same alcoholic drink category, things like a dark beer, people tend to be a little bit more elastic. They kind of view them all the same. So even within the same category, you could have different types of goods in that category have different elasticity measures, right? So it's not in here, but I always think about like, really cheap beers. I'm guessing, Natty Ice or things like that. They view High Life or whatever these are. They're probably a lot of substitutes. You would see them be more elastic. Whereas things that are like very specific, like there's only one of them, something like I don't know, McLaren or not McLaren, it's a car. Macallan is the whiskey brand. People think that there's not a substitute for that. They might be a little bit more inelastic. Okay. So this is just kind of the idea of some of these determinants that impact elasticity. We'll revisit this idea of slope. So there we go. Oops. Slope and elasticity next class. And that we can actually not just look at the elasticity of one demand curve, that actually on the same demand curve, there are different points that are elastic and different points that might be inelastic. Okay. So today we kind of talked about it as though there is just one elasticity measure for a good. You can kind of think about there is like an average elasticity measure, but at any different point or at any point on the demand curve, we would actually have a different elasticity measure for the same good. We'll talk more about that next class. Oh, I didn't want to stop share there. I wanted to exit out of this there. There we go. So for the last couple minutes here, I'm going to go to the home page, scroll down. I'm going to add this quiz. And then should be published and available to everybody. So I'm going to give you the answers since we only have a couple minutes left. I'll run through the answers here. We will start next class going through these questions just to kind of revisit what we talked about today. I'll also show you how we would calculate using like actual data, some of these price elasticities of demand. And then we will kind of jump into the remaining 20 slides, finish out some discussion about elasticity, different types of elasticities, elasticities relationship to, oops, there we go, revenue, and kind of finish these out. So for today, just to kind of make sure if you've been here during the live lecture or you watch the recording, very first question, and once again, we'll work through these at the very beginning of class tomorrow, so we'll rehash these, but just to give you the answers today in this recording, we've got what? Demand here is inelastic, right? Second one, if you do the midpoint method, you should get an elasticity of 0.54. The one that's not true about, or sorry, the one that is true about perfectly elastic demand is that the slope is 0. And then what makes demand more elastic of these four, it would be less time. Wait, that's not right. Hold on. I must already have it kind of set. Well, I have this set, so I'll tell you the answers because I can see what they are. So here, I'll change this tomorrow so that it matches up. I think I just had it typed in and I didn't select the correct answer. But here to get the correct response here would be what makes this more elastic, kind of putting in less time here. Okay, so that's I'll change this after the fact, but just for today's, well, no, I don't want that to be wrong. Now I've got to go back and edit this. How do I want to do this? Give me 5 seconds here. So if you're watching this recording, because I know that this is not set correct, Select the response of less time to make the decision, and then we'll talk through tomorrow what the correct response should be. Okay. So I typed these questions up real quick. I knew we didn't have time for them, so I wasn't super concerned with the answers. I wanted to just make sure we went through the answers together tomorrow. But these will be the answers you should select that will kind of give you full credit. And I'll end up changing this one, so no matter what you select, since it's a little set, a little goofy, that you'll get credit. But these three should be that the slope is 0 for number 3, 0.45 for question 2, inelastic for question 1. Don't worry about question 4. You can, just respond to anything, and I'll make sure if you respond to anything, you get full credit for that question. Okay? All right. So we'll review these tomorrow at the beginning of class, go through the Excel example, finish out the slides. That should set us up for maybe having a little bit of time to start some review. I'll probably choose module 4 questions to review tomorrow, but then on class Wednesday, I'll kind of open it up and really be expecting you guys to ask me the questions you have on those practice exam questions and kind of get us prepared for that first exam, which will be on Thursday. And I'll talk a little more about that tomorrow as well. Okay? All right, I'm going to stop the recording. If you have any